This keynote is to help you better understand how to do ray diagrams for curved mirrors. I'm going to start with concave mirrors and talk about the different types of rays that we can draw. There are four types of rays. The first one is a light ray that comes into the mirror parallel to the principal axis and reflects through the focal point. This is called the P ray. Another ray is one that approaches the mirror by passing through the focal point, and this reflects parallel to the principal axis. These two rays are opposites of each other. And notice that the purple lines are the reflected rays, and they converge upon reflection. Concave mirrors are also called converging mirrors. Another type of ray that can be drawn is called the M ray. The M ray strikes the middle of the mirror and obeys the law of reflection, as all light rays do, and reflects at an angle of reflection equal to the angle of incidence. I've drawn the angles in green. Theta sub I is the angle of incidence, and theta sub R is the angle of reflection. So let's look at an example. But first, we need to have an object. So let me pull something out of my hat. There you go, got a rabbit. The rabbit is our object, and I'm going to use the top here of interest. We will project light rays that reflect off of that point towards the mirror and see where they converge to find out where the ear of the image forms. So I'll start off with a P ray, and it reflects through the focal point. Then I'll do an F ray, and it reflects parallel to the principal axis. Where those two reflected light rays intersect, the image forms. And since we used the tip of the ear on the object, that's where the tip of the ear on the image is. I didn't use all four or all three types of rays because only two are necessary. You get to choose whichever two are most convenient for you. I liked, in this case, using the P ray and the F ray. Concave mirrors can form both real and virtual images, and it depends on where the object is placed. In this example, I put the object past the center of curvature, and the image formed between the focal point and the center of curvature was inverted, reduced, and real. The other kind of curved mirror we will work with are convex mirrors. First, we'll look at the different types of rays. Just like with the concave mirror, light rays could come in parallel to the principal axis, and rays that do so will reflect as if they came from the focal point. So the purple arrow shows the reflection, the dashed line shows that reflection lines up with the focal point. Light rays could also come in approaching the focal point, and upon striking the surface of the mirror, they would reflect parallel to the principal axis. This is the F ray. Notice that the purple reflections are diverging from each other. Convex mirrors are also called diverging mirrors. There's a couple of other rays that we can draw. One is the C ray, which is drawn approaching the center of curvature. Upon striking the surface of the mirror, it just reflects back in the direction from which it came because it strikes the mirror at a 90-degree angle to the surface. The last ray is the M ray, and it's exactly the same for convex mirrors as for concave. The reflection is at the same angle relative to the principal axis as the ray was. And notice again, the purple reflected light rays are diverging on the mirrored side of the mirror. Let's look at an example with convex mirrors. I brought my rabbit along for this example as well, and I'm going to start with a ray from the tip of the rabbit's ear towards the center of curvature. That's the C ray. This is really the easiest one to draw because it just reflects back in the same direction from which it came. The other ray I'm going to draw is the F ray, and upon striking the surface of the mirror, it reflects back parallel to the principal axis. Now, convex mirrors are kind of weird because since the light rays diverge on the shiny side of the mirror, no image forms over there. So what you have to do is you have to extend these light rays back behind the surface of the mirror, find out where those imaginary lines intersect, and that's where the image forms. So let's do that. The F ray extended backwards, and then the C ray extended backwards. And where those two dashed purple lines intersect is where the image forms. Again, since we used the tip of the rabbit's ear for the object, that is where the tip of the image rabbit's ear forms. In this case, since it's back behind the mirror and light rays are not actually going behind the mirror, this image is virtual. It's also reduced, but it's upright. And convex mirrors always form virtual images that are reduced and upright. Think about the mirror on a car door that says objects in mirror are closer than they appear. Alright, that's the end of the curved mirrors tutorial, and I hope that this helps you.